Okay, we're moving on to getting more into to actual integration. We've done a little bit of this before, so it shouldn't be brand new, but we're going to start talking about some properties of integration. Now that we've covered pretty much all the basics. What is integration? Well, it's the inverse of a derivative. That's our second fundamental theorem. And what is integration? Integration is the area under the curve. What is integration? Integration is accumulation. All of these things. What is integration? Integration is a limit when we're approximating. But, okay, for this one, we're going to be focusing on integration as an area under the curve to get at some big ideas of integrals before we do it like really mathematically and connect it more to this idea of the opposite of the inverse of a derivative. Okay, so I'm starting on my right side here because I pasted it wrong and I don't want to go back and do it again. But okay, we have a graph and not that much information. We're probably going to have to do a lot of math. The graph of the function f on the interval -4 to 7, so it's going from here to here, consists of 3 line segments, 1, 2, 3, and 2 semicircles, 1, 2. What is the value of the integral from -4 to 7 of dx? Okay. Well, remember, an integral is area under the curve. That's what we're focusing on here. So we have all these different pieces of areas under our curve. I hope that's a different color. I think it is. So we have this piece, this piece, this piece, this piece, and this piece. And we're just finding the area under the curve, so let's just... I'm sorry. My purple one's a little wrong. I just completely left out all this other good stuff right here. We should also be looking at this area. This is area under our curve as well. Let's just look at this like pieces. So this piece right here is a triangle. So what is the area of this triangle? Should be this color. So the area of our triangle, well, it is -4 to -2. This is 2. And -4 to, or I'm sorry, 0 to 2, that's 2. So 2 times 2, 4 divided by 2 is 2. So the area of our triangle is 2. And what I want you to do, I want you to pause the video. I want you to find the area of all these shapes right here. And when I come back, I'll have what all the areas are. Okay, so pause the video, find out all the areas of these shapes. Okay, and we should have gotten that all our things are this. This is a semicircle. The area of a circle is pi r squared. Our radius here is 2. So 2 squared is 4. So we'd end up with 4 pi. But this is only a semicircle, so we divide it by 2. So we get 2 pi. This is just another triangle. This one here, this was a semicircle on top with area of pi over 2 because our radius is 1. 1 squared, pi r squared, pi times 1 squared is just 1 pi divided by 2 because it's only half a circle. Plus this rectangle right here, which is an area of 4. And finally this rectangle right here, which has an area of 2. And before we move on here, I want to make an observation. One of these shapes is not like the other. And when I say that, I'm really not talking about the shape. I'm talking about where the shape is. Which of these shapes is different from the others? Make a prediction. If you predicted this semicircle right here, you would be correct. This semicircle is different from the others. What makes it different? Well, all the other ones are above the x-axis. All of these others are below the x-axis. So we're going to do something weird, and we're going to say that this area underneath the x-axis, we're actually going to call it negative. This area underneath here, this is going to be negative 2 pi. And now we're just adding up all our areas. So the integral from negative 4 to 7 of f of x dx equals, let's just add up our areas. It's 2 minus 2 pi plus 2 plus pi over 2 plus 4 plus 2. And when we simplify that, which I will go ahead and simplify to try and get it, it's not going to be one number, but it'll be two numbers. We get 2, 4, 6, 10, negative 2 pi plus pi over 2 is negative 3 pi over 2. So our final area would look something like 10 minus 3 pi over 2. Okay, and so we found our area. And now let's talk about actually what we did, because we applied a property of integrals here, but I didn't tell you that we were doing that. I just said we're finding the area under the curve. But let's look at what we actually did. Well, we found the area of this section here. So we found the integral from negative 4 to negative 2 of f of x dx. And we added that to the second piece, our integral from negative 2 to 2 of f of x dx. And then what did we do? Well, we added that to our third piece. I should have color-coded it, but I'm not going to because it's too late now. From 2 to 4, these are x values that I'm choosing, by the way, in case that's not clear, of f of x dx. And then we added that to our integral from 4 to 6 of f of x dx. And then we added that to our integral from 6 to 7 of f of x dx. My f of x looks a little ugly here. Don't judge it. Okay, and this is a powerful property of integration. It's saying if we have two endpoints, but we have stuff in between those endpoints, we can split it up by that. So I'm going to give us some actual important properties. These are things that you should know are properties of integrals. This first one I had us do a little demonstration for, but the other ones I'm just going to give them to us. Properties of integrals. So our first property, which is the one we just did, is our property if we have an integral from a to c of f of x dx, that's the same as if we have our integral from a to b of f of x dx plus our integral from b to c of f of x dx, where a is less than b is less than c. So if we have an integral going from point A to point C, and there's a point in between, we can split it up. So that's one of our properties of integrals. Our second property, let me make sure I'm getting it right. Okay, this is also similar to our derivative properties. If we have an integral from a to b of f of x plus or minus g of x Oops, I forgot something. I forgot something important. This is something you should start yelling at me about if I forget it. Don't forget your dx. I've been saying, don't forget your dx, don't forget your... Oh, you couldn't even tell that I forgot it because it didn't refresh, but I forgot it, and then I told y'all to not let me forget it. You shouldn't let me forget it. This is equal to, similarly, how we can split it by the bounds of integration. We can also split it by the actual pieces of integration that we're integrating. So we can split this into the integral from a to b of f of x dx plus or minus the integral from a to b of g of x dx. So that's property number 2. I should label these. And our third and I believe final property, but I won't say it's final for sure yet, but our third one that I'm giving you today, unless I decide I want to give another one, which I actually might give because I think it would make life easier if I told you all about it. This third one is that if we flip it, if we go from b to a of f of x dx, so if we switch the bounds, or if we want to switch the bounds, this is equal to the integral from negative a to b of f of x. There's our third one, and let me just make sure there's no other ones that I really want to do. Okay, there's one more property that I want to give today, because I think it just makes life a little easier when you can do this, and I used it a lot so when I was doing integration. If we have an integral from a to b of c times f of x dx, where maybe I shouldn't use c, let me actually use k, where k is a constant, k is a number, then we can say that is the same thing as the integral of k times the integral from a to b of f of x dx. And this is the last one I'm going to give today. This is saying that we can pull out a constant from our integration and it won't affect it if we're multiplying it. Okay, those are all our properties of integrals. We should know these. They should be pretty intuitive. They work similarly to the derivative work. Okay, and now let's come over and let's do our FRQ question. This is where the bulk of our time is going to be, which we've already spent like 15 minutes. But okay, let's do an FRQ question that's applying these properties of integrals. So the graph of the function f on the closed interval -3 to 8, that's this one up here, consists of 6 line segments. 1, 2, 3, 4, 5, 6. And the point of 5, 2, which is this point right here. Let me get my cheat sheet out, my key, so that I'm doing everything correctly. Okay. The function g is given by this function. It is known. These two integrals are known. Find the value of the integral from 4 to 8 of f of x dx, or explain why the integral does not exist. Okay, well, let's look at our function. We're going from 4 to 8. Okay. So let's look from 4 to 8. It's going to be similar to what we did before. We're going to split it into pieces. We have this blue piece. We have this green piece. and we have this purple piece. I'm sorry, I changed the color. It's a black piece. Let me zoom in a bit. These three pieces, we're just going to add all three of these up. And we're going to make sure to show our work for that. So this is the integral from 4 to 8 of f of x dx equals, and here the work is really just showing the numbers that we're adding. So what is the area of this first piece? This is 1 times 1 divided by 2. This is 1/2 plus 2 plus 1. Yeah, plus 1. And if you want to add that up, you can. It's 3.5 or 7/2. But really, as soon as you get to this part here, that's a safe stop. If you don't want to do any math after that, you don't have to. This is your value. And I'm going to pause and I'm going to say something that's not talked about here, but is this graph continuous from 4 to 8? No, it's not continuous. It's not continuous at 5 and it's not continuous at 7, but we still found an integral. We still found an area under the curve. This is important to note that integrable does not imply continuity. Similarly to how continuity does not imply differentiability. Differentiability implies continuity, but here we have, if something is integrable, it does not mean it's continuous. Okay, and there's a point there. Now part B, there's 2 parts for this. It's worth 3 points total between the 2 parts. And we want to find, for part 1, find the value from from -1 to 4, sorry, of g of x dx. Okay, how can we do this? Well, we have, sorry, moving my wrong screen. Okay. How do we do this? We need to use our properties of integrals. So we want from -1 to 4. This is going to be part 1. -1 to 4 g of x dx. And what we have is from -3 to -1 and -3 to 4. Well, I'm seeing something here. This is a large integral. From -3 to 4, that's a distance of 7. This is only a distance of 2. And we want from -1 to 4. So we want from here to here. Well, let's just take out the pieces that we don't want, which is this part right here. So let's do the whole integral from -3 to 4 of g of x dx. And I think I'm going to draw a picture because I don't super like how I'm explaining this in a second. But from -3 to 4, and let's take away this -3 to -1 piece. So let's subtract it. So this part right here. And let me actually draw a number line to sort of show what's happening. So our whole integral, or our biggest integral that we have, is this one right here, going from -3 all the way to 4. But we only want from negative 1 to 4, we want this piece here. So what we need to take away is this part right here, which this is that integral from negative 3 to negative 1. So that's a visual representation of what we're doing, is we are taking our whole integral, our big integral, which is this one right here. This is our whole, and we're taking away a piece of it. Sorry, I forgot to, it wasn't syncing properly. Taking away this piece to leave us only with this green piece, which is what we want. And that's going to equal to, I'm not going to sort of show anything other than that, but from negative 3 to 4 is 11.2. From negative 3 to negative 1 is negative 4.8. So this is going to be 11.2 plus 4.8. That is 16. Okay. And let me make sure I'm on track with where our points go. So this right here, it's kind of tricky, but tricky to decide where our points go. Getting to this, showing this integral property and this answer, I'm going to say it that way. This integral property right here that we used is going to get us 1 point. And getting our actual answer is going to get us a second point. Okay, now for part 2, find the value of from negative 1 to 4 of 2g of x minus 4 f of x dx. Well, our integral property here, and I'm really glad I showed us that fourth integral property now, because we're going to split this up. We have from negative 1 to 4 of 2 g of x minus 4 f of x dx. And I'm going to split this integral up. And I'm going to split it up in several ways, but I'm going to skip steps a little bit. So I'm going to split these two functions up, 2g of x minus 4 f of x, and I'm also going to pull out my constant. So I'm using properties 2 and 4 here to split it up into two integrals and to pull out my constant at the front. So I'm going to end up with 2 times the integral from negative 1 to 4 of g of x dx minus 4 the integral from negative 1 to 4 of f of x dx. Okay, and we've already found these numbers, I think. No, we found 4 to 8, not negative 1 to 4. Okay, we found one of these numbers. This one from negative 1 to 4, we found that was 16. So this is just going to end up being 2 times 16 minus, and then f of x, we're going from negative 1 to 4, so from negative 1 to 4. I'll let you pause there and find it out because I'm not going to show that work. I'm just going to say what the area is when you come back. So pause the video, figure out what the area is. Okay, I said I was going to do the areas, and then I was looking at it and I decided I actually do want to do the areas. So this is a triangle, base of 2, height of 2, 2 times 2 is 4, divided by 2 is 2. This has an area of 2. This first triangle, and then the second triangle, it has a height of 2 and a base of 1, 2, 3. 2 times 3 is 6, divided by 2 is 3. So this has an area of 3. And you should be screaming at me, but wait. This triangle right here is below the x-axis, so what should my area be? Well, my area should be negative. And then, so our integral from negative 1 to 4, what is 2 minus 3? That's negative 1. So if I come back down here, shoot, I scrolled on the wrong thing. This is -1. And then when you simplify this all together, you're going to end up getting, which honestly, as soon as you get to this part right here, this part gives you the third point. You don't have to simplify it further than that. And I truthfully recommend you not to simplify further than that, because we are all prone to making dumb mistakes. And if you miss a point because you go from here and then suddenly you think this is -4, you get 32 minus 4 and you put 28 and you lose that point, that is a dumb reason to lose a point. Do not be dumb and just don't do more math than you need to do. Don't put yourself in a position to make more mistakes. And the other thing that I want to say is, if you wrote this, I should have color-coded this better, but sync, please. Yeah. This part right here and this part right here, these were two opportunities to get the same point. So if you used your integral properties at any point during this question, you got a point for that. And then the other 2 points were for each of the two answers. So you had two opportunities to get this, to get one of these points. Okay, C. This is going to be a novel question, but it's really not going to be that tricky, I don't think. Okay. So we want the integral from -3 to 4 of this. And we're going to have to split this integral up, because this is when we're less than -1. So this is going to end up being our integral. So the integral from -3 to 4 of h of x dx equals the integral from -3 to -1 of g of x dx, because we're only moving, because that's where h of x is defined to be g of x, and then plus our integral from -1 to 4 of f of x plus b dx. And we want this to equal 14.2. Well, the integral from -3 to -1, they tell us that that's -4.8. So this equals -4.8. And then we don't know the integral from -1 to 4 of f of x, but we know the we don't know the integral of -1 to 4 of f of x plus b, but we know the integral from -1 to 4, so let's just split this up. Let's write this as -1 to 4 of f of x dx plus the integral from -1 to 4 of b equals 14.2. And if you aren't screaming into your laptop right now, you should be, because I've made a terrible mistake. I've ended the world with this mistake. That's how bad it is. What have I forgotten to do? What have I left behind that I need? Exactly right. We need a dx. I'm imagining that you all just said dx. Hopefully that's true, or it was a thought you at least had in your head. We're missing a dx. This should be b dx. Okay. And we know the integral from -1 to 4 because we just found it. It was -1. So this is going to be -4.8 minus 1 plus the integral from 1 to 4. Oops. 1 to 4 of b dx equals 14.2. We might be missing a piece in order to do this. Yeah, we are missing a piece here. So I apologize. We're not going to be able to finish this question because I don't want to give us this piece yet. We're not ready for it. But we can get that the integral from 1 to 4 of b dx should be equal to, I'm just going to add 1 to both sides, so that's going to be 15.2. Add 4.8, that's going to put us at 20. So we can get that this integral should be 20. And when we have the final piece we need, because we don't know how to actually do integrals yet. We've done all these integrals graphically, but we don't know how to actually do integrals algebraically yet. And there's a way that you can do this integral algebraically, but we're missing 2 pieces, and the 2 pieces we're missing, which I'll tell you now, and then I'll come back to this question once we've done those 2 pieces. We're missing the first fundamental theorem of calculus, and we're missing how to integrate the actual integration piece. Okay, and now coming here to part D, this is just a limit question. Find the limit as x approaches 1 of f of x divided by g of x plus 2. Let me pause really quick. Okay, I just wanted to double check myself on something. So we want the limit as x approaches 1 of f of x divided by g of x plus 2. Well, let's try substituting it in 1. This is going to be equal to f of 1 divided by g of 1 plus 2. What is f of 1? F of 1, scrolling up, is 0. And I have a sneaking suspicion where this is going. 0 divided by, and then g of 1. Well, g is this function here, g of 1. So this is going to be 4 plus 3. That's 7. Is it g of 1 or negative 1? Yeah, it's g of 1. Okay. 7 minus 10. So this is negative 20. Negative 20 divided by 10 is negative 2. So we get 0 divided by negative 2 plus 2. Yeah, I suspected it was going this route. And it makes sense to go this route. And that equals 0 over 0, which is indeterminate. And now, again, before we move on, we should have alarm bells going off because we've just done something to visually understand what's happening, but we haven't found what's actually happening. So our alarm bells should be telling us we need to cross out all this stuff that is visual ideas of what's happening, but it's not actually true. But now we can say that our limit as x approaches 1 of f of x equals 0, and our limit as x approaches 1 of g of x plus 2 equals 0. So we can use L'Hopital's rule. And here we can take the derivative of the top and the derivative of the bottom. So the limit as x approaches 1 of f prime of x divided by g prime of x equals, and that's going to be f prime of 1. Hopefully we don't have to use it again. G prime of 1. Well, f prime of 1, let's come back up here. f prime of 1, that's just the slope of this line here. That's going down 2 over 1, so negative 2. And we already don't have a 0, which is really good. And then g prime of 1, well, we have this function here. I guess I will end up substituting in. Let me write it all. So we're looking at our derivative of this. So this is going to be 1 over 10 times 12 times 1 squared plus 3 times 1. Oops, no. I forgot to take the derivative. Plus 6 times 1 minus 10. There we go, this right here. And honestly, again, this would be a safe stop. This spot right here, you get to this part, you've done that. That is the limit. And I'm gonna be smart. I'm gonna try to encourage y'all to be smart. I'm not gonna go any further. This is your point right here. So 1 point is for this answer. Oh, we actually missed a point. I missed a point. I'm sorry. Another point is this notation and citing LHOP. And the point I missed, is, which of course is the point that I did in my head, so you should know that I'm going to get punished if I try to do something in my head. Well, we have g of x equals 1 over 10 times 4x cubed plus 3x squared minus 10x minus 17. Our other point for this question is finding the derivative of this and actually writing what the derivative is. So our derivative here is 1 over 10 times 12x squared plus 6x minus 10. There's our derivative. And this would give us, this would be what we need for our, what color have I not used? Let's do pink. Hopefully it looks pretty. Normally the highlighters look pretty even when I expect the color combinations to not be pretty. Okay, that's not the greatest color combination, but we'll take it. This would be your third point here, writing out the derivative. Okay. And that is a quick one. We would have gotten on this one. The only question we couldn't completely do was part C, and we would have still gotten 1 point, out of 2 points here for using our integral properties. But we missed the second piece because we don't have the tool we need yet. But I'll make sure to come back to this question when we have the final tool. Okay, as always, thank you for watching.